Good morning, everyone. Can you hear our voice?
Yes, sir.
Yeah, thank you, sir. And with us, Dr. Pushpendra Kumar from the Central University of Ranchi, and Dr. Bhavesh Gogoi, sir, senior scientist from Assam Agriculture University. One member is also joining. He's from VSSRV, and he's from the Computer Science Engineering Department, Dr. Rubul Kumar Bonia, sir. So he's joining soon, within 5 minutes. So without any delay, I would like to request our research scholar, Rupjyoti, to start the presentation. Dean Research will be joining very shortly. And we are keeping in the recorded mode so that we'll go through the recorded version, we'll analyze the suggestions made by the members, and we'll implement the changes accordingly. So this is a very important presentation because we are going to register the title of the proposed title by Rupjyoti for his PhD work. So thank you, everyone. So Rupjyoti, now you can start.
Good morning, sir. The present slide is visible, sir. Hello, sir.
Yes, yes.
Sir, am I audible, sir?
Yes.
So, good morning to all the respected panel members. I am Rupjyoti Chutia, a research scholar of Department of IT, School of Computing Sciences, the Assam Kaziranga University. And I'm pleased to present my proposed PhD research titled AI-driven framework for real-time monitoring of nutrient deficiency in rice using leaf image analysis. And the work will be carried out under the guidance of Dr. Bora, sir. So I'm currently working at Krishi Vigyan Kendra Jorhat under Assam Agriculture University. So the contents of my proposal are the introduction, problem statement, a review of literature, research gap, objectives, study area, materials and methodology, and expected outcomes and references. So I've chosen rice as a study case because it has a significance, and the rice is a primary source of calories for more than 3.5 billion people worldwide. And India, one of the staple crop is rice, which is followed by wheat. And the largest area of cultivable land of India is dedicated to rice. So there is a need of study for this essential commodity. And next, please. Then for good productivity, for improved productivity, the management of nutrients in the rice plants is very essential, and it is also treated as an essential component of soil and plant management system. Then compulsory one is the nutrient management, as we know that the food we intake, if those are has nutritional value, then it will impact the human health. For good health, we need good food with high nutritional value. So for like that, for growing rice plants, we have to provide proper nutrients to the rice plants as to affect its yield and productivity as well as the grain quality. So we are focusing on the nutrient management, and we are going to develop some technology to provide nutrient deficiency detection system so that the farmers can easily manage their nutrients or monitor and manage their nutrients in their rice plants. So the importance of nutrient management, because for nutrient management is very essential step in any kind of plants, specifically rice. We have if we under increased productivity, grain quality for each and every purpose, for their developing their immune system, for everything we have to manage the nutrient. So the key points are there for optimal growth and development of the plant for in all the stages, then maximizing the yield and grain quality, then maintaining soil health and fertility, and also the economic benefit. The proper maintenance, proper management of nutrient will lead to reduce input cost and also increase profitability. So the nutrient management is very important. So the major nutrients required by the plants are nitrogen, phosphorus, potassium, manganese, calcium, sulfur, and many more. The the nutrients are nitrogen, phosphorus, potassium, and sulfur. So, the traditional methods for nutrient monitoring. So for managing nutrients, we have to focus on nutrition monitoring. If we first diagnose the problem, then we can provide solution to that problem. So the process in detection of or diagnosing the problem is the traditional way is for actually have some lacuna. So we are focusing on that. The first one is the nutrient status of plant, including rice, can be determined by the leaf color, which reflects the amount of chlorophyll they contain. Basically, the farmers, the growers are monitoring their farm by visiting their farms, and with naked eye, they are finding whether the crop has sufficient nutrient or not. And the second one is the ground-based remote sensors are there. So remote sensors are installed, and another one is leaf color charts and chlorophyll meters, which are actually not available to the growers or the rural or the resource constrained persons. So these things are there, the traditional methods are there, which are actually not available, or maybe due to some high cost, they are not able to use those facilities. And another one for potassium and phosphorus, we go for soil testing, which is conducted on lab. The farmers cannot directly go to the farm and find out whether it is phosphorus deficient or potassium deficient is there or not. And it again is cost, it is expensive. So both the traditional methods for nutrition monitoring, especially for NPK, is either you can say not available or maybe cost effective. So cost expensive. So some visual symptoms we have highlighting here. Especially, we are also working on especially working on the nitrogen, phosphorus, and potassium deficiency. So we are highlighting some visuals where we are depicting the nitrogen deficiency symptoms, then potassium deficiency symptoms, and phosphorus deficiency symptoms. And another one, the final one, is a healthy leaf with proper nutrition. So these are visual symptoms through which we can develop some technology to treat or use these visual symptoms to detect nutrient deficiency. So our problem statement is that despite the critical importance of precise nutrient management in rice cultivation, existing approaches for nutrition deficiency detection, such as manual inspection, already I have told, soil testing, and traditional imaging methods are time-consuming and then subjective and lack scalability. So we are going to develop an AI-driven technology through which we can especially the cost will be less, or the output will be real time, but already developed technologies, AI-driven methods, which are already available in the available. Those are actually the data sets they have used. Most of the data sets are controlled or in limited field conditions, and for the farmers, so which are actually the farm field photographs are actually not able to, actually they won't able to provide real-time solution to those photographs available